Question 7, the exam question at the end, really should be done. And we've got these line here, 2x plus y equals 9. Let's just rearrange that while we're here. That's 9 take away 2x's. And it's meeting this curve, and this one here. Now we did this in an earlier one. We want to know where they meet, so we have to put them equal to each other. So here's the curve. 3x squared minus 5x plus 3, and it has to equal the line, the 9 take away 2x's. That's why I rearranged it a second ago. Anytime we get something with squareds in, we make them all equal 0. So we've got 3x squareds here. Going to add those 2x's on, add these 2x's here on. So we get 3x's there. And take those off. So we're going to get minus 6. Isn't that nice? It can divide by 3, so let's divide everything by 3 first of all. X squared minus x minus 2 is equal to 0, and now we can factorize it. It's clearly going to be 2 and 1. Which way round? Well, it's minus 2 and plus 1 to get the value there. Well, that tells us that it equals 0 either when x is equal to 2 or when x is equal to minus 1. Now, they'd actually already done this one for us. The minus 1 one is the one we've got here, and so for that one there, y is equal to 11. For this one here, when x is equal to 2, put 2 in, well, let's do it into that one there. 9 take away 2 times 2 is 5, isn't it? So the y value is 5. And I could put the value of 2 into that as well to check it works. So what we've got to do now is actually do some integrating. And we're doing this integral. So for 3 marks, we're just being asked to do that integral. Let's see if I can see it on the page still there. So for part B, the integral of that is going to go to x cubed divided by 3, so that 3 cancels out. Then I'm going to get 5 over 2 x squared plus 3x. And there is going to need to be a plus c there because it's a indefinite integral. I haven't got any numbers to work with. Part C now says find this area, and this is going to be involved in 2 bits. First of all, we're going to find out the area under this curve here. This area down here. And that's done just by putting the values minus 1 and 2 into this formula that we just got here. So rather than writing it out again, and I wouldn't advise you do this, but I'm just going to write minus 1 and 2 round there. And I don't need that plus c now. This is just for my one here. So putting in the value 2, I'm going to get 2 cubed, that's 8, take away all of that, and that works out to give, I think that's 10.5 when we work that out. But that isn't the area we want. That's just the area under the curve. You've also got to work out the area under this shape here. Let's change colour, see if you can spot this shape here. It's the line there, down to the bottom, across there, and up there. And that you might remember from GCSE as a trapezium. Now, we could do it by integrating the line, or we could just use the rule for finding in the area of a trapezium, and that area turns out to be 24. So the area we want is 24, take away 10.5. 24 take away 10.5 is 13.5, isn't it? 13.5 units squared.